So if you're starting to look at something like this, and I'm trying to solve for x, of course, what do I need to do first? I need to isolate my x term. What has to go? Okay, the 5 does. And yes, I would highly suggest that you do it in that order. Some of you are like, well, what if I wanted to get rid of the fraction first? You could, but you'd also have to remember to multiply the -5 by 2 as well. And most of the time people forget about that. So I always just say make sure that that plus or minus goes away first. Do a little reciprocal work here. He will take care of that for me. But here's something I always find curious. A, what's my last step to solve this? And B, what are my solutions going to be? So what's the answer then? Positive and -6. Because, again, if I went to plug that back into my expression, both the positive and the negative form of that answer are going to give me the solution. Okay, so if I have a power equation, something that's squared, I'm always going to end up with 2 answers unless my answer is 0. Like positive and negative 0 doesn't make sense. So that's going to be true even if we get over here. I've got to get rid of the squared in this case first. So the squared and square root are inverses. But when I do that, similarly to what I did here, the square root of 4 is 2, but I get plus minus. Now, here's the part that people normally just are like, with. They want to just write, oh, it's like plus or minus 3, or plus or minus 1. Not necessarily. This is why I always kind of suggest people break this up. I know that x minus 1 is going to equal 2, but I also know that x minus 1 is going to equal negative 2. And I'm going to solve them separately, just because, for the same fact, I don't want to put plus or minus and get one of them wrong. Add 1 over. Add 1 over. You're like, oh, yeah, it's not plus or minus 1 thing. It's 2 completely separate answers, which is what will happen when you have a quantity that you're taking a square root of. So just something that you have to be aware of, which helps us to understand what's going to be coming with these. Now that I just got you thinking about this whole plus minus thing, when you're doing it with a square root or a cubed root, you will not have plus minuses. You will get one answer. So just to kind of keep those straight, when I get down to here, it's the same idea. Isolate the radical first. What do I have to do to isolate my cubed root of x? Add 4. Okay, so if I add 4, I've got the cubed root of x equals 4. So now think about the opposites from up above. For instance, I had square roots. I'd square both sides. Now I have a cubed root. I have to cube both sides. Cubed and cubed root cancel. I get 64, and here comes the not so popular word in this case, check. Here's why sometimes it pays to check. Occasionally you're going to get answers that will not work because you'll get like a negative square root or something bad will happen here. So just to take that second to think about it, you don't have to visibly show me, but when you're doing these, even if you're just doing it in your head, you're going, all right, let's just make sure this works. This 64, yeah, 4 minus 4. Okay, that's good. Again, I don't have to visibly see it, but I'm just warning you in case on the test you might get one that doesn't work. You might want to take that minute to check. Okay? But again, number one priority, always, 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 is you have to isolate that radical term. Whether you're multiplying it by something, whether you're adding or subtracting something like we had in number 1, you've always got to get this part alone. So what do I have to do to get that alone this time? Okay, divide by 2. And you're like, ooh, here's something different. Well, now this time, I don't just have like 1/2 or 1/3. I have 3/2. So when we're dealing with exponents like this, what power could I take both sides to get that to go away? Partially. Think about whenever you're dealing with a fraction. What can you always multiply some fraction by? The reciprocal. Because a lot of times, we think about things like, well, if I have 1/2, okay, so if I multiply it by 2, that cancels out. The same thing's going on here. I've got 3/2. If I multiply that by 2/3, everything cancels out, and I get what I need, which is to have this be isolated. So, whoops, and I'm moving things, not thinking. If I take both sides to the 2/3 power, at this point, I have 2 choices. I got a calculator with me. Sweet. I just punched this into the calculator, literally. I would punch in 125 to the 2/3. And notice I'm putting the exponent in parentheses. If you don't, the calculator will do 125 squared and then divide it by 3, which is not what you want. So you're like, you punch that in, you're like, okay, cool, I get 25. Well, what if I don't have a calculator available? What if I'm like, waiting for somebody or somewhere where I don't have one of these fancy calculators? What do? Perfect, okay? We could take this 125 to the 2/3 and say, you know what? I remember how to get this into radical form. And oh yeah, that chart that I had before that now is kind of starting to get ingrained into my memory here. I could say, oh yeah, the cube root of 125, that's on my chart, is 5. And 5 squared is 25. That is an option, okay? And it really would help some of you with the mental math that we're doing sometimes to start trying to do some of these that way. But again, the backup's always there if you need it with a calculator. So, let's see. Keep isolating. What has to be done first on this one? Subtract the 2. You always, always, always have to have your radical by itself on the side. Now what? Okay, square it, because squared and square root are inverses. Those get canceled out. Now life's becoming pretty simple. Just add my 7 over, 5 by 4, get my answer. And double check real quick. 4 times 4 is 16, minus 7 would be 9. Square root of 9 is 3, 3 plus 2 is 5. Sweet, that one works. Now, there always has to be a twist to something. Always. You're like, ooh, 4, that was kind of nasty. I'm only allowed to have, I can only have one radical per side. Because if I don't isolate those, well, that's a whole different problem. Because now I'm having to FOIL this out, and I'm getting middle terms, and I'm not getting rid of the radical. It gets to be a mess. And I wouldn't wish that upon anybody. So, if I want to move this, let's say, to the other side of my equation, I can just add it over. You're like, okay, but how am I going to isolate the x? Because normally you tell me I got to divide by 2 or something like that. In this case, this is our one exception to the rule. Once I get those isolated, now I want to get rid of the radicals. Now the left side's not bad. The squared and the square root are inverses, so that goes away. Here's the part that I have to be careful of, though. That squared, true, it's going to be the inverse of this, also is coming over to my 2. That doesn't have a radical on it. 2 squared is 4, and then those cancel. And a lot of times people will forget about that, and they'll just call it 2x. So you've got to make sure that squared goes through, and now I can just subtract the 3x over, get my answer, and say, okay, let's see. 3 times 2 is 6. 6 plus 2 is 8. Square root of 8, and you're thinking, come back to that. And then you're like, okay, 2 square root of 2. I'm not sure this one works. It does, whether you know how to break down a radical to get here, or you just punch these in your calculator, like square root of 8 is 2.82 something, something, something. And if I punch this in, I get the same thing. So yes, this does work. But that's really the only kind of trick that can get thrown at you here. Otherwise, we're doing the same type of thing. So when you get down to a problem, when we're looking at like number 7, or something nasty like number 9, or something like that, they're really not ending up being that bad. So again, isolate your x term. How's this go away? Subtract it, okay? Don't lose that negative that's there here still. You're like, but couldn't I take care of that at the same time? Maybe. If I don't want the negative, I could divide or multiply both sides by -1. So I really do want this completely isolated before I do my last step. You're like, but Harty, we haven't dealt with fourth roots before. We've done cube roots, we've done square roots. How are we going to deal with this? Yeah, whatever your root here is, just take it to that power. 5 to the 4th power is 625, and I'm good. And that's going to be the biggest thing for some of you on these, is just basically being cautious. But the rules, again, aren't going to change. We're doing 8. I still have got to isolate this. That's going to divide both sides by 3. And just like we did up in example 2, I have to take it to the inverse power. Now again, at this point you have a choice. You could punch 81 to the 3/4 into your calculator, get the answer out, that's fine. Or it's another one of those where you could say, okay, here's my root, there's my exponent. The 4th root of 81 from my chart is 3. 3 cubed is 27. Or like I said, you can just punch it in. I'm not going to have a big problem with it either way. You're going to have to know how to get through some of this anyhow. Let's see, I'm trying to find one thing that throw us for a loop here. I definitely want to do 9, and then I'll kind of open it up to see if anybody has a specific one they want to take a peek at here. All right, 9 we got to take in pieces. What do I need to do first on 9? Okay, I need to get that +4 out of there because the 5/2 is more directly connected to my radical than this is. So if I add the 4, now what? Multiply it by the reciprocal. That gets rid of this. Ten times 2 is 20, divided by 5 is 4. So it's still coming out nice. Now it looks a little more manageable. Because now I just have the radical, square it, just get what's left underneath. 4 squared is 16. And if you're going to go to all this work, this isn't the point where like 4 squared needs to turn into 8. That's what kind of gets frustrating. Minus the 8 over. Divide by 2. And you do. You just find out, again, if you keep getting whatever's furthest away from your radical out of there first, and just keep chipping away and chipping away, you'll end up getting there. So, any other ones down here that we want to take a peek at? Any of them look different than any of the others? I think we've covered everything. Kind of throw you for a loop. Okay, so here, again, if I want to get this isolated, I'd have to divide by the 4 first. Oops. Lost my exponent. So what exponent am I going to have to take both sides to? Yeah, I'm going to have to do the reciprocal again. So I'm going to have to take both sides to the 5 halves. And again, calculator could do it for you here. I understand this. So you're like, okay, let's see. If I wanted to, again, though, do it where I didn't have to punch it in. There's my root. There's my exponent. The square root of 16 is 4. So I'd have 4 to the 5th power. 1024. Holy cow. And then just subtract the 2. Big number, but it works. And again, be ready for and used to questions like I'm getting into down here. Okay? An extraneous solution is one that doesn't work. We hadn't run into one of those there, but again, that's kind of why we want to peek and check. Or a question like that right below. Marcy began solving x to the 2/3 equals 5 by cubing each side. What will her next step be? What could she have done to solve the equation in just one step? So if I'd have cubed both sides first, which we're not sure why Marcy would do that just doesn't make sense to us. If she would have cubed both sides, that just gets rid of the denominator. So what would she still have to do at this point? Yeah, she'd still have to square root. But we know better than that. What could she have done to get it done in just one step? Yeah, we could have gone, we could have taken it to the 3/2 power. That would have been a much better option. So down at the bottom of our sheet here, move it up here so we can see it, that's what you're in for on this. And again, you're solving, double checking, make sure, and then what we'll do is we'll go over this at the start of class tomorrow, and we'll start up on the review, and we'll kind of see where we're at from there. But if homework's been kind of sliding here on Fridays and into this, keep up, because I want to make sure that you're ready to go for not only the test on Thursday,